Hello students, this is another video in the series of vector calculus. In this video, I am going to discuss about dot product, cross product and some applications. First topic in this video is dot product, or we may understand it like this: scalar product. Now, what do we mean by dot product? Dot product of two vectors. A vector dot B vector is mod of A vector into mod of B vector and cosine theta. There is one concept, and that is known as scalar product is commutative. Scalar product is commutative. How we can prove it? So its proof is like, if I am considering here B vector dot A vector is B vector mod A vector mod into cosine of minus theta, where what is theta? Theta is the angle between these two vectors, A vector and B vector. So this is theta, and we know it is B vector A vector into cosine theta. We may write it like A vector mod B vector mod. It was actually B vector mod A vector mod into cosine theta. Ultimately it is A vector dot B vector. So what is obtained here? That is A vector dot B vector is equal to B vector dot A vector, and this is the commutative condition of two vectors. Now, from this dot product there are few results. So if I will talk about few results from this dot product definition, these are like I cap dot I cap is 1, J cap dot J cap is also 1, K cap dot K cap is also 1. How? I cap dot I cap is mod I cap mod of I cap into cosine 0 degree. Angle of I with I is 0. That is why cosine 0 is 1, mod of I is 1, mod of I is 1, ultimately it is 1. J cap dot J cap is mod J cap cosine 0, that is again 1. K cap dot K cap is mod K cap into cosine 0, that is also 1. So these are few properties of dot product. Now thereafter one more result in this regard is provided. If dot product is 0, then we will say these two vectors are perpendicular to each other. Likewise, we know A vector dot B vector is mod of A vector mod of B vector into cosine theta, but for perpendicular condition we will consider here this one, cosine of pi by 2, and we know cosine pi by 2 is 0. So thereafter A vector dot B vector is 0, and it is what? It is the perpendicular condition, or you can say perpendicularity condition of to vectors. It is like this. If I will talk about one application of dot product, if I will talk about one application of dot product, that is work done, and it is equal to force into displacement, that is F vector dot AB vector, that is W. So what is this force dot AB vector? Where I mean to say F vector is a force incorporated to move the object from point A to point B, and this AB vector is known as the displacement occurred. Thereafter, one more thing I want to tell you. What do we mean by I cap, J cap and K cap? Here I cap, J cap and K cap are the mutually perpendicular unit vectors. So now it's time for the next concept, that is known as vector product or cross product. So what do we mean by this vector product? That is A vector cross B vector is mod of A vector mod of B vector sine theta into n cap. And in this regard there are some results. First result is I cross I is 0, J cross J is 0, K cross K is also 0, and I cross J is K, J cross I, actually not J cross I, it is J cross K. Symmetry will be there. J cross K will be I and K cross I will be J. This I cross J is also written as minus J cross I. This J cross K is also written as minus K cross J, and this K cross I is also written as minus I cross K. Thereafter, few applications of this particular concept I will be discussing, and if I am talking about few applications, so there is one question like find the, actually before these applications I would like to discuss one more topic, then we will come to the application part. Suppose A vector is A1 I cap plus A2 J cap plus A3 K cap. B vector is, students, B1 I cap plus B2 J cap plus B3 K cap. I am interested in the cross product of these two vectors, that is A1 I plus A2 J plus A3 K. Cross product with what? B1 I plus B2 J plus B3 K. Now, how I may write it? I can take this whole term with this first, then this first, then this, with this and this and this. What I mean to say, that is A1I cross B1I plus B2J plus B3K plus A2J cap cross this particular term B1I plus B2J plus B3K plus this A3K cap cross product with this term again B1I plus B2J plus B3K. Now I may just expand these terms separately, that is A1 B1 I cross I plus A1 B2 I cross J plus A1 B3 I cross K. So this is from the first particular term, this one, plus if I will expand this second one, A2 B1 J cross I plus A2 B2 J cross J plus A2 B3, actually it is A2 B2 J cross J, next is A2 B3 J cross K, and the third term is like, if I will say from this one, A3 B1 K cross I plus A3 B2 K cross J plus A3 B3 K cross K. And as I have mentioned in this video earlier, I cross I is 0, J cross J is 0 and K cross K is also 0. And I mentioned that I cross J is what? It is K cap. Thereafter I mentioned J cross K is what? It is I cap. And then I mentioned K cross I is what? K cross I is actually J cap. Similarly, if I cross J is K, so what is J cross I? Minus K. If J cross K is I, what is K cross J? Minus I. If K cross I is J, what is I cross K? Minus J. So I will be utilizing all these values, and then what we will be getting? I am writing that A1 B2, this is K cap, plus A1 B3, I cross K is what? I cross K is minus J cap, plus this one A2 B1, J cross I is what? Minus K cap, plus A2 B3, what is J cross K? That is I cap, plus from this one A3 B1, K cross I is J cap, plus this term A3 B2, what is K cross J? That is our minus I cap. Now what we'll be doing here? We will be taking I cap common, thereafter J cap common, thereafter K cap common. So that is, you can understand it very well from this particular expression. We will be getting A2 B3 minus A3 B2, here A3 B1 minus A1 B3, here A1 B2 minus A2 B1, or it may be written as A2 B3 minus A3 B2 of I cap minus A1 B3 minus A3 B1 J cap plus A1 B2 minus A2 B1 of K cap. And you may know it like this, it is determinant of I cap, J cap, K cap, then A1, A2, A3, then B1, B2, B3. So it is what actually? It is A vector cross B vector. So this was the development of the formula which I have done here. Cross product of two vectors is written in the form of determinant. Now we are able to discuss the application of this particular development. So what is the application? That is what I was about to talk earlier. Here if I will talk about the application of this particular formula, so via this question I will discuss it. Find the area of parallelogram find the area of parallelogram. It is just like parallelogram and whose adjacent sides are I cap minus 2j cap plus 3k cap and 2I cap plus j cap minus 4k cap. So in this one we have to find the area. So students, if we will talk about the vector area of this particular parallelogram, that will be given like A vector cross B vector, and earlier I told you that is I cap, j cap, k cap, a1, a2, a3, b1, b2, b3. So we may compare it like a1i plus a2j plus a3k, and you may compare it like b1i plus b2j plus b3k. So here in this particular determinant I will be writing I, j, k, and it is what? 1, minus 2, 3 and 2, 1 and minus 4. So that will be, and you know how to solve the determinant, that is 5 I cap plus 10 j cap plus 5 k cap. But the area of the parallelogram is just like, if I will write the final area, I mean to say area of the parallelogram, that is modulus of A vector cross B vector. I mean to say mod of 5i plus 10j plus 5k, that is under root of 5 square plus 10 square plus 5 square, and ultimately it is 5 root 6. So students, what we have learned today, we have learned few things about dot product. What is the meaning of dot product? Thereafter one property, that scalar product is commutative. After that I gave you few results based upon dot product. Thereafter I discussed here the perpendicularity condition of two vectors, that is A vector dot B vector is 0. After that I discussed a formula based upon the application of dot product, that is work done. It is equal to F vector dot product with displacement. Now after that one more remark was discussed, and thereafter we went for the vector product, and I discussed definition of this vector product or cross product and few results based upon this cross product. Thereafter I proved the formula for A vector cross B vector by considering the values of A vector and B vector, and by this formula by this process I just proved that A vector cross B vector can be written in the form of determinant, and thereafter one application of this cross product is discussed, that is based upon area of parallelogram. So what is area of parallelogram? That is mod of A vector cross B vector. So before that we evaluated A vector cross B vector, and thereafter we just incorporate modulus upon this value. So finally we got the area of that particular parallelogram. So students, I think you have learnt a lot in this video regarding scalar product, cross product and their applications. I hope this video will be very much useful in your studies. Thank you so much for watching this video.